So then we get to number sets, and these are the groups of numbers that you have probably been learning through your math experience. So when you're young and just starting out to learn numbers, think like preschool, kindergarten age, you learn what's called the natural numbers. Usually that is denoted with an N, and that includes 1, 2, 3, 4, all the way on up. Now you don't know at the time it goes to infinity, but it does. These are also called the counting numbers. It doesn't include 0. It does not include anything negative. It doesn't include any fractions or decimals. Simply counting numbers. Then we move to the whole numbers as you get a little older, which basically just adds in 0. So it's the same list of natural or counting numbers with 0. Typically, we use a W to represent that. After that is integers. You're usually introduced to integers around 5th, 6th grade. That is going to add in the negatives. So you now have all the whole numbers, but you also have all their opposites. It goes to negative infinity and to positive infinity. Still no fractions or decimals. Typically, we use a Z to represent the integers. After that, we broaden out to the rational numbers. Now, rational, by definition, means that it can be written as a ratio. In other words, it can be written as a fraction. So anything that we can write as a fraction is included. That means all of these ones we've already talked about are rational numbers. We also have all terminating decimals, so decimals that stop, and all repeating decimals, because those can be turned into fractions. It includes all fractions as well, positive or negative. For rational numbers, we typically use a Q to represent those. Irrational numbers is the other set. So if I was, and you don't need to draw this out, but if I was drawing this out visually, I would have my natural numbers, and then that would be inside my whole numbers, which would be inside my integers, which would be inside my rational. Irrational is now its own thing. It sometimes is denoted with like a fancy cursive I, sometimes with a P. Sometimes it's written as Q complement or Q apostrophe because that's opposite rational. But basically, these are the numbers that can't be turned into fractions. They're the non-terminating, non-repeating decimals. Things like pi, things like square roots that we can't actually take, like the square root of 29. That's not a whole number answer. So that would be irrational. And then all of those are inside what's called the real number system. Real numbers we denote with an R. It's all rational and irrational numbers. This is separate from what we call the imaginary numbers, but we're not going to talk about those. So number sets. We can describe them with words. We can do the roster method. But either way, you're going to be using the ellipsis to show that it keeps going. So let's go ahead and just practice some sets, writing some sets. Use the roster method to write each of the given sets. So we want the set of natural numbers that are less than 5. What would be included in that? 4, 3, 2, 1. What about 0? No, that's a whole number, not a natural. And again, order doesn't matter. So you could list those ascending. You could even mix them up. Okay, the solution set of x plus 5 equals negative 1. Well, in order to do a solution set, we need to have the solution. We need to solve it. So how would I get x by itself? Good. Subtract 5 from both sides. So I have x equals negative 6. Our solution set is negative 6 in braces. There's only one element to that set because there's only one answer or solution to that equation. The set of negative integers greater than negative 4. What numbers would be greater than negative 4? -3, -2, and -1. Beyond that, there are no negative integers that are greater than -4. Questions on how we're doing this? Figure out what elements are in it. You write it inside the braces. Okay. So then we have some symbols and terms that we're going to bring into play now. And we need to know what these mean. So this first one, it kind of looks like a weird E. And that means is an element of. So, for example, I could say, and I'll write it right in here, I could say 4 is an element of the integers, right? Or the natural numbers, or the whole numbers. I could use either. But this is how we are using it. Is an element of. The one with the slash through it is not an element of. Now, this circle or 0 or O with the slash through it, that represents the empty set. It's called either the empty set or the null set. And it is empty. Oh, it can also be written either with that symbol or just a pair of braces with nothing inside. When we get to subsets in a few minutes, we will talk about how the empty set is technically a subset of every set because it's contained in every set because there's nothing in it and there's nothing to contain. Okay, a straight line we are going to use inside our brace to mean such that. If something is well-defined, if a set is well-defined, it means it is possible to determine if an element is in it or not. So, for instance, the natural numbers is a well-defined set. It's easy for me to know which numbers are in it and which numbers are not. If I said the set of all-star basketball players, not well defined because what is defining star? By whose standard? If I say the set of all, I can't even think of any. I got nothing. My mind went blank, but you know what I'm saying. Right? Do you know what I'm saying? Okay. Finite. A set is finite if the number of elements can be counted. So if I can give an actual number of how many elements are in it, then it's a finite set. Otherwise, it would be an infinite set. And then the cardinal number, which we write with n parentheses a, that basically means like the number of elements in A equals, and I fill out the number. That's the number of elements in a set. Okay, so let's look at how we would use these. So we're going to determine for these ones whether each statement is true or false. So is it true or false that 4 is an element of the set 2, 3, 4, 7? True. Is it true or false that -5 is an element of the natural numbers? False. Is it true or false that 1/2 is not an element of the integers? True. Because remember, integers don't have any fractions. Okay, questions so far? All right. So now we're going to look at set builder notation. This is a slightly different way to write a set. It gives us multiple conditions that have to be true, but it allows us to include a lot more elements. So we still are using our braces. We put an X at the front basically to say this is the set that includes all elements X such that And this is where we give our conditions. So x is an element of, and we can put the set, and x is, and we can include a condition, like greater than 7, less than 5, but greater than 2, something like that. All right, so here we go. We're going to use set builder notation to write the following sets. The set of integers. So we need to have the set of all elements x such that we have the set of integers, so we're going to start with x is an element of the integers, and then we have greater than -3, so we would say and x is greater than -3, and then we would close our brace. So this is going to include any element that's in the integers and greater than -3. So we'd have -2, -1, 0, 1, 2, 3, all the way on up. All of those would be elements. Okay, the set of whole numbers. So we need our braces. The set of all elements x such that x is an element of the whole numbers, and it says less than 1,000, so x is less than 1,000. And close your braces. So this would basically include from 0 to 999. No fractions or decimals, no negatives, because they have to be in the whole numbers. The first one that we did would be an example of an infinite set, because it's going to continue all the way through the positives. The second one would be an example of a finite set, because it has to be less than 1,000 and it has to be in the whole numbers. All right, let's look at number 3. The set of integers less than 9. So we have our braces. All elements x such that x is an element of the integers and x is less than 9. Will that be an infinite set or a finite set? What did you say, Kaylee? Infinite. Because if you look at what's less than 9 in the integers, you have your 8, 7, 6, 5, 4, 3, 2, 1, 0, but then we go into all the negatives, and that keeps going forever. The set of natural numbers greater than 4, so we have our braces. All elements x such that x is an element of the natural numbers and x is greater than 4. Would that be infinite or finite? Infinite. Good. Okay, any questions on set builder notation? All right, so then we're going to talk about comparing sets to one another. And we have two words that we need to distinguish between, equal and equivalent. Equal and equivalent are similar, and in some scenarios could be used interchangeably. But with sets, that is not the case. They mean something completely different. So equal uses the equal sign, and it means that the two sets have the exact same elements. So every element that's in one set also has to be in the other. Order doesn't matter. Equivalent, which uses this little squiggle, does not have anything to do with which elements are in the set. It has to do with the size of the set. If it has the same number of elements, they're equivalent sets. But they're not equal sets because they don't have the same elements in them. So let's look at these examples, because technically we could have ones that are both equal and equivalent, and we could have ones that are either or neither. And then we're also going to look at the set's cardinal number. So let's start with our cardinal number. We write that as n of A equals. So how many elements are in set A? 4. And n of B, how many elements are in set B? 4. Okay, because their cardinal number is the same, this implies that set A is equivalent to set B because they have the same number of elements. Now let's look at those elements. Are these sets equal? Do they have the exact same elements? Yes. So A is also equal to B. All right, let's look at example 2. So what is our cardinal number for set C? 3. There are 3 elements. What is our cardinal number for set D? 3. So this implies that C is equivalent to D. They have the same number of elements. Are C and D equal to each other? No. So C does not equal D because they don't have the same elements. All right, and let's look at E and F. What is our cardinal number for E? 3. What is our cardinal number for F? 4. So that implies that E is not equivalent to F. They do not have the same number of elements. Are they equal? No. E does not equal F. So here's my question. Can 2 sets be equivalent but not equal? Yes, we had an example in number 2. Can 2 sets be equal but not equivalent? No, should be your answer. No. Because if they have the exact same elements, then they should have the same number of elements. Okay. Some more symbols and terms and meanings. Okay, so universal set, we use the letter U, and we are referring to all possible elements that we're looking at. So that doesn't necessarily mean all numbers in life, okay, because it's whatever we're considering, and you'll see in a couple examples. But it's called the universal set, and then we look at some subsets of that. So universal set is all possible members or all the numbers, elements that we're considering. A complement, which we mark with an apostrophe, refers to the elements that are in U but are not in set A. So the complement of A are any elements that are in our universal set but are not part of set A. And I'll show you an example which will make it a little clearer. These two are easily confused, subset and proper subset. And you can see that they're very close in symbol as well. It's kind of an elongated C, and one of them has a bar underneath. So a subset means that every element of A is also an element of B. A proper subset means that every element of A is also an element of B, but A and B are not equal to each other. And I'll show you an example. But notice that the one that's not equal doesn't have that bar underneath. Okay, so think of that kind of like an equal. Okay. Oh yeah, we got to cover this first. Okay, so fundamental relationships. The complement of U is always going to be the empty set or the null set. And the complement of the empty or null set is always going to be U. That's just like known. Like there's no exception to it. If I ask you what's the complement of U, it's the null set. What's the complement of the null set? It's U. That's just given. A is always a subset of itself. So when we're breaking a set down into subsets, we always include itself as one of the subsets. And the null set is also always a subset of A. Okay, so here we go. We need to decide if these statements are true or false. Okay, so we're going to let U, our universal set, remember that means like any of the elements we're considering. It's going to be 1, 2, 3, 4, 5. For this problem, that's all the elements that are possible. Set A is 1, 2, 3, 4, and set B is 2, 4. We have to decide if these statements are true. So let's go through this. Is A subset of B? Nope, that's not what it says. Of U. In other words, is every element in A part of U? Yes. Should be yes. It's not the other way around, so we couldn't say U is like a subset of A. But yes, A is a subset of U. Okay, true. Is A proper subset of U? So in other words, proper subset means every element of A is in U, and they're not equal. A and U are not equal. Is that true or false? True. Good. I know it's a little confusing. Okay. Is B a subset of B? Yes. You should always say true on that one. Something is always considered a subset of itself. The empty set is not a subset of A. True or false? That would be false. The empty set is always considered a subset of a set. So whether it's A, B, U, doesn't matter. The empty subset or the null set is always considered a subset. The complement of A is 5. Complement, remember, means anything that's part of U but not in A. Is that true or false? True. Good. Okay. So let's look at the next one. So this says, and I'm going to list A here. A was 1, 2, 3, 4. Okay, we're going to talk through all of the possible subsets of A. Okay, so here's our set A, 1, 2, 3, 4. If I'm breaking this down into all of the possible subsets, I will always have the empty set or the null set. That would be the subset with 0 elements. Then I have subsets with only 1 element. Okay, so I could look just at 1 as a subset. It would have 1 element, just 1 in it. I could look at the subset with 2 in it. It only has 1 element, it's the number 2. but it's a subset of A because 2 is in A. I could have 3, and I could have 4. Okay, so these so far are all subsets of my set A. I could also have subsets that have 2 elements in them. So I could have a subset of 1 and 2. I could have a subset of 1 and 3. I could have a subset of 1 and 4. I could have a subset of 2 and 3. I could have a subset of 2 and 4. I could have a subset of 3 and 4. Those would all be subsets that have 2 elements in them. They're all still subsets of A. Okay, I could also have subsets with 3 elements in them. So I could have 1, 2, and 3 in my subset. I could have 1, 2, and 4 in my subset. I could have 1, 3, and 4 in my subset. I could have 2, 3, and 4. And then I can have a subset with all 4 elements. 1, 2, 3, 4. In other words, itself. A is a subset of itself. Okay, how many subsets possible there? 16. 16 total subsets from set A. Now, no one wants to write all these out every time. So we have a system for figuring out how many subsets we have. And what we do is we raise the number 2 to the power of the number of elements that we have. So we know that the number of set A, our cardinal number, is 4. So I can figure out how many subsets set A would have by taking 2 and raising it to the 4th power. That means 2 times 2 times 2 times 2, which is 16. Questions on that? Yes?
So n is the cardinal number?
N is the, yes, N with the parenthesis and the name of the set in it. So N of A is the cardinal number. Yep. And then we put that as the exponent. Questions? Yes, Kaylee.
The cardinal number is how many terms are in it?
Yes, how many elements are in it? Yep. Other questions? I think you will come up with more questions as you do your assignment. Okay? All right. So your assignment is written on your paper. It's section 2.1, 2.2. I think there's 30 problems total. Due Tuesday when you come to class on paper. We'll still try to do like a few minutes of like a few questions if you have any. But do your best. Email me if you have any issues. You have 5 minutes if you want to start it, or if you want to head out, that's fine too.